Okay, we're looking at solving simultaneous equations, but this time with a difference. We're looking at one being linear and one is not linear. Now, there are two methods on this course for solving this type of equation, and the first method is a graphical method. So we have here, using graphical methods, well, we need graphs. Now, the graphs are usually drawn for us. When we've got the graphs drawn for us, or we draw them, we're looking where the two graphs intersect each other, where they meet each other. So we'll go through this now. So we've got this equation here, which is 2x plus 3y is equal to 0. And we either plotted for us or we plot it. If you plot a graph, don't forget you always label it. This question here will probably be drawn for us, or this graph here will be drawn for us. Again, label it. And then we're looking at solving this simultaneously. Simultaneous means at the same place. So these two graphs at the same place here and down here, which I'm now going to indicate by the two blue dots. And then finally, once we've done that, we're looking at what the x value is and what the y value is. The y value is 2 and the x value is minus 3. And over here, again, we're looking at what the x and y values are. And the x value here is 3 and the y value is minus 2, which I'm now going to put on the graph. But strictly speaking, we should finish it off by writing it down. So for example, here is we've got x is equal to minus 3 and we've got y is equal to 2, and we've also got another solution which is down there, which in this case is x is equal to 3 and y is equal to minus 2. And that's the end of the graphical approach. We're now moving on to the algebraic approach. The algebraic approach is, it doesn't change. You must always look for out of the two algebraic expressions, you must always look for the linear expression. And when you've identified the linear expression, which is here, you write it off to one side. And then when you've written it off to one side, you need to actually make either x or y the subject of the equation. Now you want to avoid fractions, so given the choice that the x has got a coefficient of 1, you need to make x the subject of the equation, i.e. you want x to be equal. So x is going to be equal to 1 minus 4y. Bring the 4y over, it becomes minus 4y. Now what we do is we write down the original nonlinear equation, and what we're going to do now is fill in for x. We are going to replace the x, and we know that we just worked out that x is equal to 1 minus 4y. So now we're going to replace the x using the empty bracket method. So 2, open a bracket, and it's going to be x is equal to 1 minus 4y, close the bracket, and then we've got squared, plus 3, and we're replacing the x again, so the x has an empty bracket on it, 1 minus 4y, close bracket, and then there's a y at the end, and is equal to 35. We need to work out the 1 minus 4y all squared. So I'm going to do the working out over here, just because it makes it neater. So 1 minus 4y to be squared is equal to 1 minus 4y on 1 minus 4y. And that's now going to be 1 on 1 is 1, 1 on minus 4y is minus 4y, minus 4y on 1 is minus 4y, and minus 4y on minus 4y is plus 16 y to be squared. And then we do a tidy up line, 1 minus 8y plus 16y to be squared. So we're back over on the left hand side and we're going to fill that in. So that's going to be 1 minus 8y plus 16y to be squared plus. Now what I'm going to do with this y here is I'm not going to work out anything. I'm just going to move it up and put it into this position here. So it's going to be plus 3y on 1 minus 4y is equal to 35. Now we're going to do a tidy up line. So we're going to have 2 minus 16y plus 32y squared plus 3y minus 12y to be squared. And we're going to bring the 35 over. We're going to have minus 35 is equal to 0. Now we're going to tidy up, focusing on the y squareds first. So 32 take 12 is going to be 20 y squared. And then we've got minus 16y plus 3y is minus 13y. And then finally we've got a plus 2 minus 35, which gives us minus 33, and that is equal to 0. We're now going to do the first multiplied by the last, and we're going to get minus 660. And looking for a factor pair that is going to add up to minus 13. And what has been quite nice about this is that we've already got it, because in the multiplication above, 20 minus 33 actually fits what we need. When we add 20 to minus 33, we get minus 13. Very often this is the case on these problems, where they're really testing you on can you solve simultaneous equations rather than giving you a complicated quadratic to work out. Okay, so we can move to the next line. So we're now going to split the minus 13y. So we've got 20y to be squared plus 20y minus 33y minus 33 is equal to 0. The common factor for the first pair is going to be 20 and it's going to be y, and inside that's going to leave us with 1y plus 1. So we can repeat that over here, 1y plus 1. Traditionally, choose the minus sign, look for the common factor, which is 33, and then check to see if it works. Indeed it does. So now we can finish off the factorization. 1y plus 1, and in the side the other bracket, 20y minus 33 is equal to 0. So we can now finish this off, that y plus 1 is equal to 0, and 20y minus 33 is equal to 0. So y is equal to minus 1, and 20y is equal to 33. So y is equal to 33 over 20. We've now got the y values. We need to find the corresponding x values. If we have space, we can continue down the page. If not, we can go to the empty space on the right hand side. What we now do is we go back to the highlighted linear equation, which I'm just asterixing now at the top of the page, and we write this linear equation, if we have room, underneath the two y values that we've just worked out. So we've got x is equal to 1 minus 4y, and here we've also got x is equal to 1 minus 4y. And now we put in the corresponding values of y. So x is equal to 1 minus 4, empty bracket, minus 1. And working that out, we get x is equal to 5. On this side, we've got x is equal to 1 minus 4 on 33 over 20. So x is now equal to, and we need to use the calculator. So 1 minus 4 bracket, fraction button, 33 over 20, close bracket, press equals, and we get minus 28 over 5. And to finish it off, we should write them together. So what we have now is we've got x equals 5 when y is equal to minus 1. And we also have x is equal to minus 28 over 5 when y is equal to 33 over 20. And we can write those as coordinates if we so choose, 5 comma minus 1 and minus 28 over 5 comma 33 over 20.